Ever wondered about the basic building blocks of matter? It's a fascinating journey to the very heart of our universe. You see, everything that exists, from the vast galaxies to the tiniest speck of dust, is made up of basic particles called atoms. Now, atoms aren't just simple spheres, they are complex structures composed of even smaller particles. Picture them as tiny solar systems, with a nucleus at the center and electrons whizzing around in orbits. This nucleus is further composed of protons and neutrons. So we have electrons, protons, and neutrons, the three musketeers of the atomic world, each playing a unique role. The electrons carry a negative charge, the protons a positive charge, and the neutrons, well, they are the neutral ones. Together, they make up the atoms, which in turn make up everything in the universe. But how did we come to know about these particles? Let's dive into the history. The discovery of the electron was a landmark in the world of science. Now let's dive into how this discovery came about. In the late 19th century, a physicist named J.J. Thomson was conducting experiments with cathode rays. These rays were mysterious streams of light that were emitted when an electric current was passed through a gas at a very low pressure. Thomson noticed that these rays were deflected by an electric field, indicating they were made up of charged particles. But here's the kicker. They moved away from the negative plate and towards the positive plate, suggesting that these particles were negatively charged. Thomson had discovered a new type of particle, smaller than an atom and carrying a negative charge. These particles were later named electrons. This was the first time anyone had discovered a subatomic particle, fundamentally changing our understanding of the atomic structure. Thomson's discovery paved the way for a deeper understanding of the atomic structure. But electrons weren't the only subatomic particles waiting to be discovered. Enter Ernest Rutherford, the man who would change our understanding of the atom once again. Through a series of experiments involving gold foil, Rutherford found that atoms had a concentrated central core or nucleus, which was positively charged. This revelation led him to the discovery of protons, the positive counterparts to the negatively charged electrons. Yet there was still a piece of the atom puzzle missing. James Chadwick, a contemporary of Rutherford's, stepped up to the challenge. He hypothesized the existence of a neutral particle within the nucleus, a particle with no charge that balanced out the positive protons. After a series of experiments, Chadwick confirmed the existence of these neutral particles, which he fittingly named neutrons. With the discovery of protons and neutrons, the picture of the atom was becoming clearer. With these key players on the atomic stage, we were ready to delve deeper into the mystery of matter. Now, let's take a closer look at Thomson's atomic model. Back in the late 19th century, a brilliant scientist named J.J. Thomson proposed this fascinating model, often referred to as the plum pudding model. Imagine a delicious pudding where the dough represents the positively charged sphere, and the plums, or the raisins, represent the electrons scattered within. However, like all scientific theories, Thomson's model had its limitations. It could not explain the scattering of alpha particles observed in Rutherford's gold foil experiment, nor did it account for the existence of the atomic nucleus, a central region of concentrated positive charge. This led to the replacement of Thomson's model with Rutherford's nuclear model of the atom, which better explained these phenomena. Despite its limitations, Thomson's model was instrumental in shaping our understanding of atomic structure. It formed the foundation for future atomic theories and models. Thomson's model was a stepping stone towards understanding the complex world of atoms. So we've journeyed through the discovery of the subatomic particles and the development of atomic theory. We've delved into the discovery of electrons, those tiny particles with a negative charge. We've ventured further into the nucleus, understanding the positively charged protons and the neutral neutrons. We've seen how these particles come together to form the atomic number, leading to the concept of isotopes and isobars. We've also examined Thomson's model of the atom and its limitations. We've seen how this plum pudding model, while a significant step forward in our understanding, wasn't able to explain certain phenomena, leading to further advancements in atomic theory. We hope you've enjoyed this exploration of the atom's building blocks. Remember, every great discovery started with a simple question, just like the one we started with today. Thank you for watching. Don't forget to like, share, subscribe to Facts Academy 0122, and leave your comments below.